I would go and use your algebra nation book. If you're not using your algebra nation book, I know you're not trying. Do not write the question. Pay. That's a good sound. There you go. There you go, Miss Gomez. As long as you took the notes from Tuesday, you'll get your answer. It's in the algebra nation book. But don't write the question, just answer it. Algebra nation book? It's in there. I mean, if we didn't get to that point, then you didn't get to that point, but. How do you, Henry? Cover your face for me, Mr. Chair. Make sure you check with me, Mr. Phillips. Welcome. Write down in your agenda if you got your agenda for me, Henry, when you're done. Yep. Oh no. Take away, Miss Helen. Y'all are throwing up a bunch of goose eggs today. All right. I guess let's go ahead and talk about it. So, when I ask you to take your algebra nation, but Henry, what page is that on? Everybody turn your pages to books to 161, please. 161. Good old 161. Sorry, 163. Please do so for me. And I want you to, did everybody actually get that done? Like during the video? Like when you were watching the video, did y'all get to it? So like, remember when I asked y'all to go home and finish it? You didn't get done with the video, right? So my class is a continuum. It means it never stops. It means that the day before is going to have something from today, it's going to have something from yesterday. Tomorrow is going to have something from today in it, and the day before. It's a continuum. It never stops. This Algebra Nation book is your best friend. When I tell you to open it up and look at it, there's a reason. When I tell you to take notes, there's a reason. There's a reason for all of it, okay? So let's go ahead and start. We have to write, oh, they're asking, is this in standard form already? Is this in standard form? Yeah, standard form. So what we want to do is go from standard form to vertex form. Now, I'm already going to tell you, M is wrong, or vertex is wrong. So the first thing that you have to do is, and I've actually labeled it step by step. This is the formula that you use for completing the square. This is what they're doing here, completing the square. The first rule is you write out the quadratic. I wrote the quadratic out. If you don't have this on your bell ringer and if you're not writing it right now, that would be silly. All right, so after you write your quadratic out, the second step is I'm going to group just the quadratic and the linear term. I'm giving you step by step of what to do. So I grouped my quadratic and my linear and I left a space to complete the square. And then I put my +5 on the outside. What I have to do is I have to complete the square right here. Where did that plus? Okay, so I did +16. Okay, so now if my A is greater than 1, I have to factor out whatever is in both as a number in this part where I grouped. If my A is greater than 1, in this situation it is greater than 1, so I have to take out a 4. When I take out a 4, the 4x squared becomes x squared. The 16x becomes 4x. The 4 is on the outside now. That +5 is still on the outside to the right. Now we are about to complete the square, and what Emma did wrong is about to be very obvious. All right, so I'm going to use the formula b over 2. So the b divided by 2 squared. My b, you're going to use on the inside of the parentheses. So my b is 4. I have to do 4 divided by 2, which gets me 2. 2 squared gets me 4. Now, that's how I completed the square. I then write my answer 4 in that space that I left in the parentheses. But I have to get the number on the outside to the right. To get this number on the outside to the right, I have to do the opposite, so subtract, and then multiply the number we got times this number that we factored out. So 4 times 4 is 16, and we're still going to subtract it on this side. So we're almost into vertex form now. And now we just have to look on the inside of the parentheses, because when you complete the square, you now have a perfect square trinomial. All right. So x squared is a perfect square. 4 is a perfect square. Okay. So let's check the middle. One factor from the first term is x. One factor from the last term is 2. So 2 times x is 2x. Double it. That gets me 4x. Does that match the middle? Yep. So it's a perfect square trinomial. So that means I can write one factor as an a, this factor as a b, but they're square roots. So the square root of x squared is x. Square root of 4 is 2. X plus 2 squared is the factored form of this perfect square trinomial. I keep the 4 out front, and now I'm going to do the mathematics. 5 minus 16 is a negative 11, and that is the correct vertex form that Emma did not do correctly. Her vertex that she thought was right was a negative 2, 1. The vertex that is correct is a negative 2, negative 11. Take about 30 seconds to make sure you write everything that you get. Make sure you write in your agenda that it's topic 7, transformations of the dependent variable of a quadratic. It's day 24, week 14. And what we're going to do is we're going to go over topic 7 today. Yeah. I don't know. Could somebody answer Adrian's question? Where does the -2 in the vertex come from? I mean, I know, and you guys should know already because we've been dealing. So not one of you can answer that question? All right, look it up and find it out, okay? These are the questions that when you're actually going through it, you should be asking. Like when you're having questions as you're going through the material. I mean, like when we actually learned it the first time so you would know what you're doing. But I'll explain. So where's the only 2 in this whole function? Right there. So that's where you get that part from, which we just took a test on. So please write this on your yellow piece of paper. We're doing topic 7, transformations of dependent variable of quadratic functions. This is the easiest lesson that you will be given this year. What I am doing right now is I'm passing out the last of your assignments that I took the time to make sure and touch up and put your grades into your grade book before those progress reports came out. Make sure the white summatives make it to the white summative section. If it's a summative, it should be hole punched and put to that summative section. This is the only thing that's not white that should be in your summative section, your factoring packet. Okay. Put your phone away. All right, so it's still the same thing, transformations of the dependent variable, you can still copy it. Our success criteria for the day is I can apply vertical shifts, reflections, stretching, and compressions to a quadratic function. And we've already done this. If you look at the standard, you've had like 4 questions on tests already this year just about this. Remember what K does. All right, so it says, identify the effect on the graph of replacing f of x with f of x plus k, or k times f of x, or f of k of x, or f of x plus k, which we're about to get into and you're going to see great examples of. All right, so this is, we're on page 164, so all of your algebra books should be open. So consider the graph that you see on the board. That graph comes from the table that you see to the left. Every x value has its own f of x value. So -2, 4, 2, 4, -1, -1, sorry, 1, 1, 0, 0. These points correspond to this graph. What we're going to do today is we're only going to make changes to the f of x. What's another way of saying y value? If x is an input, what is f of x? Output. If x is the independent variable, what is f of x? So with that in mind, that means we're transforming just the y today, the dependent. Okay, so let's get into a couple examples. So look, they're going to always give you a table or they'll give you a graph. But the reason why you have 5 different lettered functions here is because all they're doing is taking f of x and changing it just a little bit. In this first one, they're saying f of x is going to just be a y value plus 2 for every y value. So if I wanted to change f of x, the y values would have to just be changed. G of x is just 4 plus 2. So my first point would be a -2, 6. Or if I wanted to create a function that's going to do another transformation, I would subtract 2 from the y value. Or I would multiply 2 to the y value. Or I would divide by 2 with the y value. Because all we're trying to do is to find what type of transformation has occurred. And if it's a negative in front, you're just making your f of x values negative. You're about to see some great examples of that right now. Okay? This is your first example. It is an XY table. They have your x points and your f of x points. What they want you to do is they want you to make a function g of x that has been transformed. All this is saying right here is that I want you to take f of x, which is your y values, and I want you to add 2 to it. So if g of x is f of x plus 2, I'm going to take my f of x, which is 4, and I'm going to add 2. So my new y value here is 6. With h of x, it says f of x minus 2. So that means I have to take my y value and subtract 2. So when my f of x is 4, h of x's transformation says I'm going to subtract 2 from it. So my new y value here is 2. If you all could, please take the next 3 minutes to finish this table, okay? Hey, Siri. Set a timer for 3 minutes, please.
Okay. Your timer is set for 3 minutes.
Take the next 3 minutes to fill it out. Mr. Kirsch, you should be in your book. One 164. And if you really want to be a RAID boss, after you find whatever your value is for the y, you would then take your x and your new y and write an ordered pair for it. So I would have g of x somewhere, and then under it I would have my new 5 ordered pairs. The x values are going to stay the same because we're just transforming the f of x values. Another minute and a half. And if I go too fast, there will be a video posted on Canvas at the end of this period. If you get done, go ahead and attempt to try to graph with the graph right beside it. And here are the answers so you can check your work. Got another 30 seconds. All right. So those are your answers. All we're doing is adding 2 to the y values for g of x, and we're subtracting 2 from each of the y values for So now we have to graph. So to graph, you have to find your points. I now have my x values for the three functions. There's f of x. We're going to graph g of x and h of x. All right, so the first point for g of x is -2, 6. So I'm going to go to -2, and I'm going to go up to 6. Next point, I'm going to go to -1, and then 3. So -1, 3. Next point, 0 and 2. Next point is 1 and 3. The last point is 2 and 6. 2 and 6. And then we're going to connect them. Sorry, it's hard for me to see from all the way back here. I'm used to connecting them back here. So let me connect them back here. And that is called g of x. So if I wanted to graph h of x, I would probably do a different color, and that would be what would be right. And I'd do -2, 2. So -2, 2. Our next point would be -1, -1. So -1, -1. My next point is 0 and -2. So 0, -2. My next point is 1, -1. So 1, -1. My last one is 2, 2. So 2, 2. And then that would be h of x. So from this point, what point is this right here? 0, 0. So from this point to this point, how many spaces do we move up on the y-axis? 2. So when we are adding numbers to y variables, when we are adding positive numbers to our f of x values, what does it do to the function? What did it do from f of x to g of x? What happened? Camden, say it again, please. I'm dying. It moved up 2 units on the y-axis. So up 2 units on y-axis. Welcome, Miss Leap. No? No. So what about this other one? This is 0, 0, but that's f of x. So what was the change between f of x and h of x? It went down 2 on the y-axis. So when you are subtracting numbers from your f of x variable values, it makes it go down on y-axis. All right. So getting there. Now, let's go to the next graph that you see. To the right, it's on page 165. And I've kind of given you some examples. So they want you to do 3 different functions this time. All right, and I'm going to point out, it says m of x is equal to 2 times f of x. So what that means is I'm going to take my f of x and multiply it by 2. So if my f of x is 4, 2 times 4 is 8. So that means 1 times 2, 0 times 2, 1 times 2, 4 times 2. The one in the middle, it's 1/2 f of x. Just divide by 2. So if your f of x is 4, it's 4 divided by 2, I got 2. 1 divided by 2, you're going to make a decimal, which is 0.5. Okay? And then in the last one, all you do is you take your f of x that they gave you and you make it negative. You're really multiplying by a -1. But if they gave you 4, it becomes a -4. If they gave you 1, it becomes a -1. Get it? Cool? All right, so take the next 4 minutes to try to finish this table for me. Hey, Siri. Set a timer for 3 minutes, please.
Your timer is set for 3 minutes.
This is why everybody should have a calculator in their hand. I'll go ahead and turn the lights on because I want you to compute. If you need a calculator, go grab it. Please watch your eyes. I know you guys got this. Mr. Carey, please cover your face. Proud of you. Way to work hard. Uh, 0.5. So finish up the graph, and then we're going to talk about one of the last problems. Tomorrow you're going to graph them on the graph. And I would write out the order pairs, the new order pairs that I get. If it was me, so my m of x order pairs would be like -2, 8, 1, 2, 0, 0, 1, 2, 2, 8. So I didn't get them confused. And if you really, really want to be a boss, you could try to graph them, which we have time, so let's try to graph them. So I know my m of x points is -2, 8, so -2, 8. I'm going to do something up here. -1, 2, so -1, 2. 0, 0, so the origin stays the same. 1, 2, so 1, 2, and 2 and 8, so 2 up 8, and I guess that's going to be right there. If I wanted to connect them. Ooh. And that is m of x. Now I have to make a different ink color. So now let's do n of x. First point is -2. Where's my cursor? Okay. So -2, 2, -2, 2, negative 1.5, negative 1, and I'll make it like halfway, so it would be like right there. Next one, 0, 0, so it stays at origin for that point too. 1.5, so 1, no, 0.5, so like right about there. And then 2 and 2, so 2, 2. So if I had to connect all those points that I just made, make sure you're writing your arrows, and that is n of x. And the last one we're going to do is p of x. So the first point for p of x is 2, 8. So I'm going to go 2 of 8. Wait, wrong. Sorry, 2, negative 4. So 2, negative 4. Negative 1, negative 1. Zero, 0. Okay, they all 1, negative 1. So 1, negative 1. And then 2 and negative 4. Which is the reflection signal. And if I want to connect all those points, oh, and that is p of x. So m of x did it get stretched or did it get compressed? Black is f of x, red is m of x. So when we multiply a number by 2, what happens? Yeah, so m of x looks like it got skinnier, right? Okay. So when we multiply by a whole number, it skinnier, it compresses, okay? Now let's look at n of x. N of x is the blue. When we multiply by a number in between 0 and 1, so a decimal or a fraction, it gets wider, it stretches. And then when we make a function negative, what happens? It reflects over what axis? The x-axis. Okay? Question so far? Almost done, guys. You guys are doing such an amazing job. Okay, so this is the last problem I want you to attempt. I want you to take the next 8 minutes. You can work together. I want to see how close you can get to the right answers. Hey, Siri. Set a timer for 8 minutes, please. So try this last part. And I would write it in your Algebra Nation book because this question is in your Algebra Nation book. Last period. Try it. See how far you can get on the beat the test. Most of my midterm questions are going to come from beat the test questions. Hint, hint, nudge, nudge, wink, wink. So attempt it. K, I'm going to give you a hint. K is the number you either subtracted or added, or multiplied by it, or divided. Okay? So think of K in terms of the number that we were subtracting or adding y to, dividing y by, or multiplying y by. Does that make sense? K is the number that we are multiplying f of x by, or subtracting f of x, or adding to f of x, or dividing f of x by. Cover your nose, please. Thank you. Huh? We literally just went over it. So I'll revert back so you can see it. So f of x is black. M of x is a compression. It got skinnier. F of x is black. N of x is blue. Blue stretched. See if you can get the right answers. And then we're done for the day. Huzzah, huzzah. See how close you can get.
Is this when the those are my points that it's when A, the AMX?
So it should be, we're taking 2
Mhm.
and that's why it's 2, it's not -2. So we're multiplying this 2 by it. So it's 2 times 4, which is 8. 2 times 1, which is 2. 2 times 0, which is 0.
So what about the graph? What about the graph?
So it would be this point. From here. We're about to find out. Another minute or two, and then we're going to go over it. Two more minutes, and then we are going to finish up for the day. I really want to give you a lot of time to think about it, to think. Try to think it through, you know? Because these are the questions that they're going to ask you about. 100%. These are the ones that they're going to ask you about. Think we got it locked in? Think y'all got an answer yet? Let's see. All right, so let's work on it together. Let's see. So, where is my cursor? Okay. Let's do this first one. Why did my cursor disappear? Okay. So f of x plus k, where k is greater, pay attention, than 0. So they're saying when k is greater than 0, so when k is greater than 0, an example would be the plus 2, because that's greater than 0. What happened with those? What do we do with this graph right here, with g of x? What happened with g of x? Okay, so what does that mean we're going to do with this problem? E says it shifted f of x, shifted f of x up k units. Agreed. What about this next one? When your k is less than 0, what do you think it's going to be? It's going to shift down, so it's going to be b. We're gonna do the one that everybody is for certain about. Let's do the last one first, then we're gonna do the two hardest ones. So when your k is -1 and it's being multiplied to f of x, what happens? What's that last one? Huh? What happened when I multiply by a -1? What happened when I multiply by a -1? Who said, Jenny, what did you just say? Let's see. You're going to reflect over the x-axis. When you are multiplying by a negative number, you're reflecting over the x-axis. So C. You're good. And now let's do the two that is always the most confusing. So when you're multiplying k to f of x, where k is greater than 1, what happens when you are multiplying by a number greater than 1? So m of x here is when we multiply by a k greater than 1. What happened with m of x? What happened with m of x? F of x is here. A, let's see what A says. So compressed because it came skinny, yes. And by process of elimination, this one's going to be D, because it's vertically stretched. Because it's between 0 and 1, that means it's going to be a fraction or a decimal, okay? So what I want for y'all, if you use the calculator, please put it in the washing bucket. Make sure you stack your books nicely, stack your folders, make sure your folders are arranged, okay? Super proud of you. Thank you for working so hard.